for our first example involving improper integrals, you see here that we have the integral from 1 to infinity of 4 over x squared dx. I got this written in red, and I've got it written in red because I'm going to do this the incorrect way first, because it is quite possible that this type of problem will come up in the free response section. And the reason they're placing it there is they want to make sure that you are using proper mathematical notation. All right. So in the way that we've learned to solve definite integrals so far, we say, okay, well, first we have to take the antiderivative. All right. So we think of this, we say, okay, well, the 4 can come out front. All right. And we have the integral from 1 to infinity of 1 over x squared, which is really x to the negative 2 dx. All right, if we just rearrange it, so now we can go with reverse power rule. So when we take our antiderivative, the 4 remains, and then the x to the negative 2 becomes x to the negative 1 over negative 1, and that's evaluated from 1 to infinity. All right, and now that we have that, maybe we need to rewrite this, and so the x can join the negative 1 down to the denominator, or the negative can move up. Either way, we end up having negative 4 over x, okay, and that's being evaluated from 1 to infinity. And so now we plug in the infinity, so we have negative 4 over infinity minus, and then we have negative 4 over 1, and negative 4 divided by infinity, well, that's going to be 0, because negative 4 divided by a large number, any time you divide by a large number, you're getting that 0. So this is equal to 0 plus 4 because of the double negative. So the final answer must be 4. All right. If you show that process right there, that's not going to get you any credit, because we're trying to do the definite integral process, right, with an indefinite value. Okay, that's not a number. Infinity is a concept, not a number. So what we've got right here, we don't want. All right. That may actually be the correct answer. We'll see in a moment. But we need to show it in the appropriate manner. Okay? And when we're dealing with infinity, just like we did with Riemann sums and anything else, we need to deal with a limit. All right? So the first thing that we want to do, and we're taking this, is we want to actually get a definite value. Okay? So we don't want infinity right there. We want to make this, all right, the integral from 1 to something else. All right, now when we think about the limits of integration, we're usually talking about a to b. All right, so let's just put b up here. That's my upper bound. All right, now what's happening to b? B is heading towards infinity, so I'm going to take the limit as b approaches infinity. B is a number. All right, it's getting larger and larger, but b is a number, so I now have a definite integral happening. Okay, I still have my 4x squared. I guess I can make it 4x to the negative 2 if I want to, in that regard, and I still have my dx. Okay, but what I've done is I've gone to this limit notation, and that limit notation is the correct manner in which to solve this integral. Okay, now we can proceed as normal in that we have the antiderivative of 4x to the negative 2, and just like before, that's going to become 4x to the negative 1 over negative 1, okay? And our bounds are still 1 to b, and we still need that limit notation out front. So we have the limit as b approaches infinity of 4x to the negative 1 over negative 1, evaluated from 1 to b. Okay, so that limit needs to stay there until we actually take the limit, okay? So what we're looking at now is, I'm going to head down here. We have the limit as b approaches infinity, and we can rewrite this. We have negative 4 over x going from 1 to b. So this is going to be the limit as b approaches infinity. And we have negative 4 over b. We can plug b in because b is a number. All right, it's a number that's getting larger and larger and larger, but it is a number. All right, minus negative 4 over 1. Okay, and now we know that as b is heading towards infinity, this expression right here becomes 0. All right, so what we end up having here is 0 plus 4. Notice that I don't have the limit notation anymore because I've taken the limit, and I know that this limit will be 0. All right, so I have 0 plus 4. So yes, in fact, the final answer is 4. But now in the blue ink, I have the correct notation for arriving at that answer. If you don't use the limit notation on the exam and it's a spot in the free response section, they're not going to give you the points for that section.